And I will do the same thing. All right, so for the, and it says here to round to 1 decimal place. So for the lower limit, it's 30.1. And for the upper limit, it's 33.9. Is that what you have?
I'm still.
Okay. I do rush through things, so always say, hey, Matthew, slow down
Okay.
if you need me to.
Okay. Okay. I got it. The same.
You got it?
Yeah.
All right, so part B. Part B says to obtain the margin of error by taking half the length of the confidence interval. So the confidence interval is 30.1 to 33.9. So we need to calculate this width. Okay. And you get that by taking the right and subtracting the left. 33.9 minus 30.1.
Which is.
Did you get 3.8?
Hold on. Yeah, I got 3.8.
Okay, fantastic. All right, part C. Part C here says to obtain the margin of error by using the formula. It's like this is out of order. It's weird. We already have the Z alpha divided by 2. That's this 1.645. So we'll just say it's 1.65. That's the rounded answer. You know, sometimes these Pearson are sort of, they don't give you things in the right order. I don't understand how you're doing this, but that why they're doing it this way. But the last part here is to determine the margin of error. The margin of error is half of this interval. So it's half of this is 3.8 divided by 2. So the margin of error is the width of the confidence interval divided by 2. 3.8 divided by 2 is 1.9. All right. Any questions, thoughts on that?
No.
Okay, this time is for you. So if anything is unclear, please, tell me, or otherwise we'll just go through the questions in order. Is that okay with you?
That's okay with me.
All right. Okay, here we go. It says, according to a study of political prisoners, the mean duration of imprisonments for 33 prisoners with a chronic post-traumatic stress disorder, PTSD, was 32.3 months. Assuming that sigma equals 39 months, determine a 95% confidence interval for the mean duration of imprisonment mu. All right, can you tell me what X bar, N, and sigma are from this passage?
So it clearly states that sigma is 39.
Sigma is definitely 39. Good. How about N and X bar?
The X bar is 33.
33
No.
is the number of prisoners,
Oh. Okay.
not the average. So N is 33. What does that mean X bar is?
32.3.
Yes, and there's certain language you're looking for. They don't exactly say it, but I mean, it's kind of out of, you're an English speaker, so it's not that weird, but the mean is 32.3. All right. So when it's a 95% confidence interval, that Z alpha divided by 2 is 1.96.
Yeah.
All right. So the formula here is X bar plus or minus Z alpha divided by 2 times sigma divided by the square root of N. If you have a reference sheet, you can always send that over. I'm happy to use those formulas for the lesson here, but you have everything. X bar is 32.3. Z alpha is 1.96. Sigma is 39 divided by the square root of 33. All right, what kind of calculator are you using?
It's a TI 84 plus
Perfect.
CE.
Okay. So the nice thing about the TI 83 and 84 is you can enter it exactly like this. You can do the plus first and then the minus, then the first, uh, minus and then the plus. Do you have any questions about how to enter this in the calculator? Because I do have a virtual TI 83 I can share if I need to.
Um, I heard someone told me, or the substitute on Monday told me, like, in order, you have to, like, put parentheses in it or no?
Yeah, so here's how you could enter this in your calculator. 32.3 plus 1.96 times 39 slash the square root, which I guess it puts that symbol, 33, like that. All right, so go ahead and enter that for us, please.
Okay. Uh,
And round it to one decimal place for me. What is your, let me know what you get.
okay. Okay. Hey, you said round by one
One
decimal?
decimal place, yeah. What did you get?
45 for the top, for the plus 45.6, I think.
Very good, very good, yeah. Now, here's the power of your calculator. If you hit the second and then enter, which is really entry, it'll recall the previous line and you could just go back and change the plus to a minus rather than re-entering it. Yours might have a copy and paste feature. I don't remember. But that second enter there in the lower right, it'll recall the last line and you can go back and change this plus to a minus.
Yeah.
If you don't want to do that, then you do have to re-enter it.
Okay. And then I'll do it for the.
All right, so quick question. It looks, I got kind of bumped here on the Pearson. Only one of us can be logged in at a time.
Oh no. Yeah, I'm doing good. Want to close the door? Yeah. Sorry.
Was able to get back into it. Just be best maybe to wait to log in until after we're done for tonight.
Okay.
Did you do you have that lower bound now when you subtract?
I'm doing that right now.
Okay.
I got 18.9, or do I just round that to 19?
Yeah, it'd be 19.0. Perfect.
Zero, yeah.
All right, very good. Now, the next part of the question, and by the way, do you mind telling me who your instructor is for this class?
His name is Jeffrey Krug.
Okay. There was a guy teaching this class for like 5 years that everyone tried to take, but it wasn't him. Um, but I'll bring that up another time. I have some old exams potentially to be helpful. So there's certain language that they use in these conference intervals. It is always this we can be or we are. Like that's the accepted language. Okay. So
Okay.
it's the same numbers, 19.0, 45.6, but you're gonna see that on a test. Like they're gonna have like what is the right language, and you're gonna know that it's we are or we can be. Is that okay?
Yeah.
All right. All right, so we're up to question 14. I'll snip it in. Hopefully this is going okay for you.
Okay.
All right. It says a 95 confidence interval of 19 months to 47.2 months has been found. So the margin of error. So the confidence interval width is 19 to 47.2. So can you give me this width, please? Can you subtract, 47.2 minus 19?
Got it. 28.2.
All right, so it's 28.2. Now the margin of error is half. It's half. So 14.1 here and 14.1 there.
Okay.
Margin of error is half the width. That's why you're adding it and then subtracting it.
Okay.
Is that clear?
Yeah.
All right. So the next question. Oh, let me snip this in. Sorry. Just keep all right. So the how do I want to say this? Like these are like hard because um I guess I just need to give you the answer. I believe the answer is B. Um, because it's the maximum error is the width, and you're estimating mu.
Yeah.
So I don't know. I mean, you said your tests are not like the Pearson.
No, they're like
Yeah.
how
Yeah.
we do in class, but
Okay. So, maybe when we get close to the test, we can work on more of the class problems and we can just work on these here. Okay. The
okay.
required sample size to have a margin error of 11 months with a 99% confidence interval level is. So this is another formula. This is Z alpha divided by 2 times sigma divided by the margin of error. Where? Did you see that in class? This formula?
I have not.
Okay. So I guess I don't know what to say. Um, well, this 99% confidence interval goes with a z-score 2.58. That's another one to sort of add to your table.
Oh,
It's
okay.
2.58 times sigma. Sigma is given in the problem up here somewhere. There you go. It says use sigma equals 38. I was looking for that.
Yeah.
And then the margin of error of 11. Now, very important here is you always round up. You always round up. You'll see on the test, there'll be a multiple choice answer. There'll be the non-rounded number and then the rounded down and maybe even rounded up number is always rounded up. So could you calculate this for us, please?
38. I got 79.4, I
Okay,
think.
so what should we do with that answer?
Round up to the nearest
Round up. So what does that round up to?
80.
80. Yeah, it's always a whole number. Good. Okay. Find a 9% confidence interval. Okay, so let me grab a snip. Part B. All right. Find a 9% confidence interval. So we know that what do we know? We know that X bar plus or minus Z alpha divided by 2 times sigma over square root of n. But what are we supposed to use for n? Okay, sorry. I now I see what's going on. So they're giving you information in a previous part of the problem. This is kind of confusing. So you can see why this would be frustrating to students. So they're telling you X bar is 36.3, and they're telling you that the sample size is the one from part C, which is 80. And then sigma is 38. All right. So for a 99% confidence interval, that's a Z of 2.58. Just if you haven't figured it by now, we're just doing the same thing over and over again. We're putting this, different numbers, but in the same equation, which sounds simple, but you got to put the right numbers into the equation. All right. So we got 47.6 for the plus. Could you do the minus for us?
Sure. Um, I got on the calculator 25.3, but do you round up?
Nope, just for the number. This is for the one that finding sample size. So those are your two answers there for those two boxes.
Okay.
All right. Hopefully you're getting more comfortable with this.
A little bit. Yeah.
Uh-oh. I didn't like the answer. Uh, okay, what is wrong here? 99% use mean sample size. Huh. I don't know what the error is. Maybe if a sample of the size determined part C is a mean of 36.3, 99%, 2.58. But this one threw it back. It said it didn't like it. Sigma is 38 square root of 80. Oh, I put the wrong, it's 47.3. That's probably the answer issue. Do you know if it kicks back if both of them are wrong or just one of them is wrong? That was the issue. Just one of them is wrong. Okay. All right. Okay. Um, So I'm going to go back to the other screen for a moment because I think you need to see this. It better help do the homework.
Okay.
All right, so you're seeing the question 15 now?
Yeah.
All right. Have you clicked on these icons before where it says, view the data?
Yeah.
And then this one you can actually open in what's called StatCrunch. Are you using StatCrunch at all?
No.
Okay, this is so useful for this. Because it would take forever to do this. So I'd like to show you this. Um, I know you can't see that. So let me go to that window. All right, so you're seeing the StatCrunch window.
Yeah.
So you can graph this, and we just want to do basically a dot plot of the data. You choose the data value, hit compute. Sorry, that's not what I wanted. I chose the wrong graph. Sorry, we don't want a dot plot. Great. We want to do scatter plot. Where is the Y variable? Huh. Let me try to figure out why we can't just get a plot of this data. Chart, histogram, stimulate box plot. All right. I apologize. This was going to be a big reveal, but it really isn't. We were just going to graph this data and see what it looks like, but that doesn't seem to be the case here. So let me go back to the other screen. But you may want to use may want to use this for this. So normal. I'm sorry. It's a normal probability plot. That's the issue. Okay, sorry. Now I know why now I know it's not why it's not giving us what we want. Okay, sorry about that. Let me go back to that. And if you go to stat graph, we're looking for let's call it a QQ plot. I have no idea what I'm talking about. They didn't cover this in class, did they?
No.
So it's the graph that looks like this. So that kind of goes up and to the right. So back on the other one, ooh, so it's between A and C. I know you can't see that. I don't know how you choose between those. All right, I believe it's C. Forgive me if it's not right. Okay. Part B wants a box plot. Let me go back to that. So part B wants a box plot. So this is why it's so nice to have the stat crunch. Have you not been using it at all?
No, because they haven't been recommending
Okay.
it to me.
Well, to do the homework, it's really, really better,
Okay.
at least in this case. So where is box plot?
Sure.
There it is. Sorry, I am tired.
That's
You
okay.
run out of energy. So here, see how it's going the wrong direction? You can edit it and then you can plot it horizontally and then it'll look more like it's supposed to. So if you go back to the other window there, it looks like it's hard to do. Looks like this one. And then histogram, you got to do the same thing. Go back to that other screen. So I actually really like StatCrunch. I find it incredibly useful for this class only. You can see there's a picture of the histogram,
Oh, yeah.
but they use different widths. So we got to use their widths. Their widths are, so we got to edit this thing. So we want to start at 96.5 and go up by 0.5, it looks like. You probably can't see some of these things. Goes and go by 0.5. Width. Why does it like that? It's greater than zero. It is greater than zero. Oh, I got a comma in there. All right. So now, I don't know. Can you see this histogram, the blue?
Yeah, I can see it.
Okay. So that matches the option C, which I know you can't see, but I'm clicking on that anyway. But wait, there's more. So that, it even does what's called a stem and leaf, which you probably had to do at some point. And you can see that it looks like here. Um, and then you just try to match it up to what you have there.
Okay.
Ends up being B as far as the answer. So I don't know. Maybe that was it. My gosh. Um, all right. So we can go back to, okay. So this is why it's so useful. Let me go back to, I know you're not seeing all the things I'm doing when I click the answers, but let me go back to this. So it wants you to do a 99% confidence interval. So StatCrunch will do all that for you. Okay, so if I go back to the StatCrunch and I close out, like, I got all this extra stuff open just to get rid of that. So if you go to stat, vstats, one sample with data, you have data in variable one, and then you want a confidence interval. You want a 99% confidence interval. And we do know the standard deviation, it's given in the problem as 0.58. I know maybe this looks really complicated, but if you do this a few times, you'll say, wow, this is way better. There's the confidence interval. They're giving you that they do the calculation for you. Now you probably don't get to use StatCrunch in the class, but for the homework, it's pretty useful. It'd be really hard to enter all that data in your calculator. So it's 97.86 is the lower limit. I'm typing that in now. To 98.33 is the upper limit. I apologize, a lot of switching screens, but maybe that's somewhat clear. Don't know. So
Yeah.
one can be 99% confident, one can be 99% confident. The true population mean of body temperatures. I'm trying to look here at the differences in the words. That this confidence interval contains the true population mean. Looks like it's that last one there.
Okay.
Okay. All right. How are we doing here? Because we got, 15 minutes left in our lesson ish. Do you want me to sort of move ahead? We doing order? Okay. What would be best to help you?
Um. Wait.
You want me to just keep going through these in the order here?
Yeah. Keep going.
Okay. All right. So this one, we'll go back to the other screen. Okay. Grab a snip of this. All right. So we're finding the margin of error. The margin of error is the Z alpha divided by 2 times the sigma divided by the square root of n. All right. So your for a 95%, your Z alpha is 1.96. Your standard deviation is 15, and your n is 4. So you want to calculate this for us, please.
Okay. Okay. I got 14.7.
14.7, good. So part B is the same thing, except they say change the sample size to 16. Okay, so it's
Okay.
like change everything. The only thing you're changing in this formula is the value of n. 1.96 times 15 divided by the square root of 16. So go ahead and calculate that for us, please.
I got 7.35.
Good. Now, what do you notice about the difference between A and B? Did it get bigger or smaller?
It got smaller.
Smaller. So as the sample size increases, as n increases, the margin of error decreases. And that's something that you're going to see on a test or a quiz, something like that. Part C is the same calculation, but now for a sample size of 64. So that's 1.96 times 15 divided by the square root of 64. We would expect the margin of error to get even smaller.
I got 3.675.
Surrounds to 3.6. All
Yeah.
right, so the last part here of this, explain your reasoning. So it says because the sample size blank by a factor of blank from part B to C. So to go from B to C, we went by a factor of 4 times 4. So it increased by a factor of 4. But what happened to the margin of error? Well, it was reduced by, well, how much? Well, it looks like it was reduced by 2. Sorry, they have divided by, and we'll say, there we go. Okay, they say it's divided instead of reduced. Okay. All right. I'm gonna skip 17. You get infinite like checks on the problems. It's
Infinite?
not numerical, it's
Oh, yeah.
all right. So here we go. This is 18. All right, a variable has a mean of 100 and a standard deviation of 16. 16 observations of the variables have a mean of 118 and sample solution 32. Determine the observed value of the standardized version of X bar, the studentized version of X bar. Okay, so the I don't understand what they're doing here. Sometimes I don't even know what they want, truthfully. Let me view an example. Let's see what they're doing. All right, so for part A, they want X bar minus mu over sigma divided by the square root of n. And the the value of X bar is 118, mu is 100. The standard deviation is 16, and the number of observations is this right here. All right, now in terms of how you enter this in your calculator, you gotta be super careful. I don't know if you have like ability to do a fraction in your calculator, but if you don't, you have to do the numerator first, then a parentheses, 16 slash square roots 16, close, close, like that.
Okay. Crud.
So go ahead and work that out. Let me know what you come up with.
Okay. Oh, oh no. Now I have to start.
Any questions on how to enter this, or you got a number for me?
Um, I don't know if this is correct, but it said 4.5.
It is 4.5. Very good. All right. So part B is what's called the P. The only difference between this is that it's X bar minus mu, but instead of sigma, it's S over the square root of N. So it's really the same numbers except for the value of S. Ends up being, and you'll see it up here in the original, it says sample standard deviation. That's S. The standard deviation of 16 is sigma. So you just have to replace S with 32 square root of 16. So I'm going to give that a calculation a try, please.
Okay. I got 117.2.
Way too big. It's got to be more like this. Did you copy and paste this second entry?
Oh no.
Okay, you might want to do that rather than re-entering it. If you don't, you have to enter it with all the correct parentheses.
Okay, I'll try it. Okay,
Do you have
this,
an answer for me?
yeah, 2.25. Is that right?
That is correct. Good.
Yeah.
Okay. Next question here is you're looking at a T table. All right, so this is going to be a little bit more difficult. So the T distribution has two things. It has this value 0.005, and then it also has what's called the degrees of freedom. It's a shape parameter. All right, so let me grab the table and see if this is even, yeah, this is what we want here. So the way to use this table, and you do have to learn how to use this. I wish there was a better way, but there just isn't, is you first identify which column you're in or which row. So degrees of freedom is 5, DF is 5. So you're in this row here. And you can see that like there's all these corresponding values. So 005 is this one, the 4.032. Now, if you didn't understand that, we will do a bunch of those types of T calculations, but you will also be able to use the calculator to do some of those. All right. So good news is like there's only like one more numerical question. The rest, well, two more. The other ones can be done. They're kind of just multiple choice things. So you think you can get your grade up reasonably high after this. All right. So here is a problem. They're giving you the mean, the sample size, the standard deviation, and the C. Okay. Now for a 98 confidence level, your alpha is 1 minus C, which is 0.02. You divide it by 2, that's 0.01. Your degrees of freedom is the sample size minus 1, 16 minus 1. So you have to be able to remember that. And then you go to this table, and this time you want the 15th row on there. All right, so I'm going to snip that in. If you don't fully understand it, that's okay. I mean, you'll do more practice in class. So you go to your table here, you find the 15th row. There's the 15th row. And this time we want 0.01, 0.01. So that's this one here. That's the 2.602. The reason we need that number is to do this confidence interval. This confidence interval is using this margin of error. So it's X bar plus or minus T alpha divided by 2 times S over the square root of N. You have all these values. The X bar is 28 plus or minus 2.602 times 6 over the square root of 16. These are going to give you the two numbers for your confidence interval. I know I'm rushing through this a little bit, but I want to make sure we get this, done for this lesson here today. All right. So that is 31. Wow, we gotta go 3 decimal places. 31.903 for the higher one. And then 24.097 for the lower one. I'm going to check those. Hopefully they are correct. And it did not like that. Okay. What went wrong here? So when I rush, that's also an issue. 2.602, 6, 16, 28, 28 plus 2.602 times 6 divided by square root of 16. I don't know. Let me check on a different piece of software that I use. All right, 0.01, 15 degrees of freedom, 2.602. Yeah, 28 plus 2.602 times 6 divided by square root of 16. I don't know, maybe I just didn't enter them right. Huh. Oh, yeah. So your teacher made the Pearson kind of strange where it doesn't give you both answers. These were correct. I just entered one of them wrong. Okay, there's probably enough there that you can get like 90 to 95% on this homework, but we do have to stop here for today. Lessons are about 50 minutes long.